Material 1 introduced to electrolysis. Material 2 quantitative electrolysis. Material 3 electrolysis of molten sodium chloride.
Galvanic or voltage called a spontaneous redox radiation is used to produce all electric currents. Electrolytic electric current is used to drive a non-spontaneous redox radiation. CU5 plus Zn kuadrat plus AA sampai CU kuadrat plus AA plus En5. Before we get into electrics, let's review the structure of a voltage call so we can convert it to an electronic scale. So a voltage call uses a spontaneous redox radiation. An atom of zinc would have to lose 2 electrons to turn into zinc 2 plus. So loss of electrons is oxidation. And oxidation if all counting at our zinc electrodes. So the zinc electrode must be our ions. Remember, oxidation occurs the anodes, and you can remember that by an ox. The zinc electrodes is also pure of electrodes. So these are negative electrodes, and thus electrons move in our words to produce an electric current. When turned to electrons, reds or copper electrodes, we know we have copper 2 plus ions in solution. So copper 2 plus ions in solution, and when thus copper 2 plus ions gain their 2 electrodes, copper 2 plus turns into solid copper. So copper forms at our copper electrodes here. So this is radiation. Gain of electrons is radiation. So radiation is occurring at our copper electrodes, making this the code hard. Remember red cat. Red cat is how to remember the one. So the copper electrode must be our positive electrode. The radiation is potential. The standard called potential. 0 is protective. 1/10. Remember a positive volt for your potential means a penetrance radiation, so we produce an electric current. The radiation is potential. The standard called potential. 0 is protective. 1/10. Remember a positive volt for your potential means a penetrance radiation, so we produce an electric current. Let's compare that valence scale to an electrolytic. An electric current is used to drive a non-spontaneous redox radiation. So if we look at the overall radiation here, we're starting with solid copper and zinc. The plus ions is selection, and we're going to CU5 plus Zn kuadrat plus Ea sampai CU kuadrat plus Ea plus Zn5 is the reverse of the radiation we just take out solution and solid zinc. So this is the about trying the radiation for this reverse of the radiation.
Here we plan a little about the material of electrolysis scale and electrolysis.
if a current of 5.0 is applied to the electrolyte cell above how much? 2 in deposit on the zinc electrolyte after 1.0 hour. Remember, an electrolyte cell uses current to drive a non-spin dose relaxation. So we need on external voltage power, and so here our better we know electrons come from the negative terminal of the bitter and electrons are forced onto zinc electrons. We know that R02 plus ions in a solution, so if 02 plus gains to electron 02 plus is reduced to solid zinc. So we're going to from here. At our other electrodes, the better pulls electrons away from copper and solid copper is oxide, so we close. From copper and solid copper is oxide, so we close the from 2 electrons to from 2 plus. So the copper electrodes lost mass over things when we close at our problem. This a quantitative electrolysis problem because there's studying a current of 5 or 0 amps, how much zinc in grams. Deposit on the zinc electron after on hour. So we have to figures of how much zinc on hour from on our zinc electrodes. So first we need to think about the definition for current. So current, let me read this down here. Current is equal to charge of time. So in space is equals to current charge is represented by key and time I lowercase t. IQ per t.
Electrolysis of molten sodium chloride. Here's a simple flat diagram. To Cl chloride I, Cl2G plus 2A chloride means to Na plus I plus 2A to NaI. 4.35 x 10 chloride 4 mole. 4.35 plus 10 chloride 4 to Na plus I plus 2Cl mean I to Na A to ClG. How long does it take to produce 1.00 x 10 squared 3 kg of sodium with a constant current of 3.00 x 10 squared 4A? A. Q per T, C per S. 300 x 10 squared 4 Q per T. 1.00 x 10 squared 6 per 22 squared 22.44 9 and A 4.35 x 10 squared 4 mole and a 9 per mole. 4.35 x 104 mole A mean x 96.500 C per mole A mean. 4.20 x 10 correct for 3.00 x 10 correct for 4.20 x 10 correct 9 per t 1.40 x 10 correct 5 38.4 horse. How many liters of Cl2G at STP 1 atom will be produced? 2Na plus I plus 2Cl mean I. 2Na I plus Cl2G 4.35 x 10 squared 4 mole. Na per Cl2 2 per 1. 4.35 x 10 squared 4 per x to 21 points 750 mole 21 point 750 x 22.4 4.87 x 10 squared 5L Cl2 PF nRT 1 atom V 21.105 mole or 0.021 273.15 273.15 V 487 x 10 correct 5L